And freely as well. Yeah. Like, I didn't hear Sam say hi. I saw him wave, but there it is.
I specifically did say hi to you.
Right.
Hello.
The audio and the video are very badly synced.
Oh, that's not good.
Oh no, it caught up again.
Is there a description listed somewhere of the tools that are used apart from this? Yeah, I imagine it's probably around that. Here it is. I should hope so.
Okay, it is 1 hour afternoon in Vancouver, British Columbia. That means it's time for the meeting of the IETF PPM working group. That's Privacy Preserving Measurement. We are going to need a note taker to take minutes for this session. We can't proceed with the session until someone volunteers to take notes. All right. I note that you are also listed as a potential speaker.
I am playing support for them rather than actually speaking. So if I need to get up, I will ask someone to speak.
Okay. Thank you to Martin Thompson for volunteering to take notes for this session.
Watson Ladd in the chat volunteered as well.
Great. Great. If you can both take a look at that collaborative document, that would be great help, probably easier for both of you. Many of you have been here all week, but maybe not all of you, so you might have missed the note well. This is the reminder of various legal obligations and other kinds of obligations that you incur by being present here. If you're not familiar with this document, it is very important that you familiarize yourself with it because it is legally binding on you. So if you haven't had time to review this, please do so. If you aren't sure if it applies to you, you might not want to participate until you've had a chance to review it. This applies, of course, to all sessions at the IETF. This one is the same as always. In addition to the note well, which principally covers IPR legal obligations, there are also some other things that you should know. We do our best to interact respectfully, and we participate in the IETF as individuals. So whatever you may feel about organizations to which other people in the room might be affiliated, please don't project that onto them. They are real people who are here talking to you. If anybody has technical difficulties, it's possible that this slide might provide you some useful tips, but otherwise, please feel free to reach out to any of the different support channels to try to resolve those issues during the session. Oop, that slide is out of date. Okay, this is our proposed agenda for the session. The next thing on our agenda is the agenda bash. If anybody would like to argue for a different agenda than this one, I'll take 1 second to give people a chance to look at this proposed agenda and tell me if they'd like it to change in some way. Okay, seems like maybe it's all right. The next item on our agenda. Oh, thank you. Tim?
Thank you. The agenda is fine. I just wanted to remind folks who are in the room, out of consideration for remote attendees, please try to identify yourselves when you come to the mic because we can't always tell who's speaking. Thank you.
Thanks for that reminder, Tim.
Chris Patton, I wanted to, this will probably come up with Ben's stuff, but we should probably have a brief discussion about the feedback from SAG yesterday, which is, well, we kind of talked about what to do with fancy crypto. Where should it land? Is it the CFRG's responsibility or not? I think having a short discussion about that would be good. Not making any decisions. I don't think we can right now, but just see what people's thoughts are.
Okay, thanks for that note. Hopefully we'll have time toward the end of the session to get into that topic. Okay, the next item is to talk about the heavy hitters consensus call. So we had an interim session. Many of you were there, but not all. We had an interim meeting, and some folks in this group laid out a range of options about what we might do in relation to the heavy hitters problem. In that session, it seemed like there was consensus to drop heavy hitters support from the DAP document at the point that, in the version that ultimately will become RFC for the first time. The chairs confirmed that consensus on the mailing list and called consensus for that change. The current version of DAP now implements that change. That means anything you've heard about Poplar 1, for example, no longer appears in that draft. And some other elements of the DAP protocol that were needed to support that have been removed. I want to emphasize that this is not a charter change for this working group. The working group is chartered to think about the heavy hitters problem. That continues to be the case. So if you have proposals that are relevant to that problem, they are potentially in scope for this working group, but they, at this point, won't be in the DAP draft. Tim?
Thanks. Nick in the chat pointed out, I suppose this is in response to Chris from a minute ago, rather than heavy hitters. Perhaps once we're done with this heavy hitter slide, it'd be helpful for those of us who weren't there to summarize whatever happened at SAG that Chris just alluded to.
Okay, that seems like a good point, and I think we will get there. But now let's move on to the DAP active issues segment with Chris Patton.
The version 2 I asked to present. It's got to be this one. I hope it's this one. Let's find out. Okay, sweet. Okay, welcome everybody. So 45 minutes, that's quite a long time. I don't think we'll need all of that time. I want to go through the remaining substantial issues that are against the DAP repository. We definitely have a lot of editorial work to do. I think what the editors would like to do after kind of landing on what the protocol is going to be, we're going to spend a lot of time like cleaning up and making it very pretty. But yeah, I think we feel that we're basically at the end. So the issues I'm going to talk about are what we feel are the issues that the real architecture questions that remain. If of course anyone is implementing this right now and wants to bring up concerns, you're welcome and encouraged to. We don't feel this is necessarily like the best designed protocol in the world. We've been deploying it, we've been experimenting it for a little while now, and we feel pretty confident that once we get through these things, we'll have settled it. But please keep providing feedback. So, so changes since 118, we did not meet in Brisbane. We had an interim, as Ben mentioned, but I wanted to quickly highlight the major changes since then. So in draft 9, so there's this concept of a query type, which kind of defines how reports can be partitioned, and then what is the scope of a batch that is collected. So we have two types that are specified in the draft. It's an enum, so you can specify more if you wanted to. We have time interval, which is, I think hopefully obvious, and then fixed size, which is, I think, less obvious by the name. But the semantics of this is you have a minimum and maximum batch size, and the leader gets to pick any batch it wants, any batch of reports, as long as they're not overlapping. In draft 9, we made the max batch size optional because it seemed less useful than we thought initially. In draft 10, we got some feedback from Mark Nottingham that we incorporated. Thank you, Mark, if you're in the room. I think that we probably still have to do HTTP dir again, but we'll see as things gets closer to the end. In draft 11, we merged the change that removed support for the heavy hitters mode of operation for Poplar. I do want to clarify one thing, Ben. The draft still mentions it. You can still use Poplar, like technically, but it's not a very exciting thing to do. You do have like a sparse histogram that you can aggregate with like some specified histogram buckets. But you can only do like a very limited amount of stuff with that. So we might end up removing that at the end of the day, but that's where things are. So multi-collection is no longer possible. I also wanted to mention there's been issue open for a while about drill down. This is when you have a batch and you want to kind of split it up in some ways, do a little bit of investigation, look at different like subsets of clients and so on. We decided to close this without any action. The reason being there are ways to address this kind of at the VDAF layer rather than at the DAF layer. So if you wanted, you can define a variant of Prio that kind of preserves the semantics that were discussed in that issue. And then also we're developing another VDAF called Mastic, which provides much of the same functionality, but in a much more privacy-preserving way. Okay. I'm going to do these in order of the PR. So each of these issues, I think there's 5 of them we're going to discuss. Each has a PR associated with it. This PR reflects the feedback that we've gotten just from talking to people. Folks, some of you might know we have like a weekly sync where some of us implementers get together and talk about issues. Anyone is, by the way, welcome to join that. Yeah, so these are kind of resolutions to existing issues. So the question for you all today is, which of these are we going to merge? Which of these are we going to close and resolve in a different way? So the first question is about the maximum batch size. This turned out to not be useful. So the proposal, and it's also kind of annoying to implement. So the proposal here is to just remove this altogether. And we also have some like related nitpicks in terms of naming things. So we want to rename query type to batch mode. This seems to align better with the intended semantics. I think there was some misunderstanding about what like mechanically is happening based on the name query. So we would like to resolve that. And then we would rename fixed size to just leader selected, which is like, the kind of the only condition that matters for this particular batch mode. We also made an observation about a Sybil-like attack in which the leader can attempt to partition reports, all coming from the same client. And so this is, you still have to fulfill the batch size. So this is not a super strong attack. But it's worth noting because we have discussion of Sybil attacks. So that's that. It's mitigated by, for example, using OHTTP or something like that we can do for other Sybil attacks. Go ahead, Martin.
Try a minute. This Martin Thompson. So it seems to me like the security consideration here is kind of the key. And one of the reasons why the original was kind of appealing in a way was that it didn't give the leader as much control, or it seemed like it didn't, when in fact it probably did.
I actually don't think that's true. I think the only change here is that there's not a cap on the batch size.
Right.
So this batch mode really does give
it's really the
leader quite a lot of control.
Yeah. I'm sort of wondering whether we need to consider new constraints on the leader's mode of operation here. for numerous reasons. One of the things that Ben and I have been discussing about the anti-replay aspects of this is that it is much easier to implement the anti-replay side of things when you do that based on time ranges rather than individual record identifiers and whatnot. And if this were a time span query, then it would be much stronger from an anti-replay perspective, because you could say for reports appearing in this span of time, potentially you could just say, I'm not going to take any more reports during that time window, and you're done in terms of anti-replay, which is a really powerful thing. So I'm thinking that may be a better way to sort of start to frame this one. The goal here is to give the leader the ability to control the size of batches, provided they meet the minimum. And we can do that with a time span type system. The only problem is, of course, the submission timestamps can be a little bit ragged at the frontier, but that's probably manageable.
So the fixed size was introduced at a time when some people were making observations about operational or potential operational issues with time interval. We'll have to go back a few IETFs in our mind to remember what those are. I wanted to comment though on the replay protection bit. The requirement in the draft is that replays, you never process a report more than once across an entire task. And then we have binding to tasks. So I agree. I would say that in my experience, replay protection is much, much easier for time interval than it is for leader selected, which is, I would like to solve that problem. Personally, I would like this not to exist from the perspective of my implementation. But I don't think it's a security issue. I think it's an operational issue.
Yeah, so I think time interval as specified is perhaps too rigid, and that's why we have this. And if this were leader selected time interval, then I think we may actually be in the sort of sweet spot there. Maybe that's the way to suggest a.
So let me ask you in terms of procedure, are you okay with?
Procedurally, this is a step forward.
Okay.
So go ahead with this.
So your vote is merged, but let's revisit. Yeah, that sounds like a good idea to me. Any other feedback on this issue? Tim, go ahead.
Thanks. Okay, so let's see. First off, I support taking this change, as previously discussed. Second, I wanted to respond to a specific thing that Martin just observed. Sorry, I'm going to get the details wrong if I try to explain it. But for a while now, like, we've been batting around something that we have called in some context time bucketed fixed size, which I think probably hits the balance that Martin Thompson was getting at, in the sense that it's leader selected batches, but there's essentially like a guarantee about the span of time that a batch will fit into, such that then I think you could do the more efficient anti-replay checks that Martin was getting at. So I think, so again, that's like orthogonal to the question whether to take this change. I think we agree on moving forward with it. So I think what I will do is try to put together some of the materials that my colleague Brendan Pittman has put together over the last couple of years about this, and like circulate them, I think, to the list so that we can all take a look at it.
So I'd say let's open up a new issue and start discussing this. We probably have discussed this on other issues before, but cool. Anybody else? So I'm gonna, I don't know how you want to do this procedurally, but I want to, if there's no objection, we'll merge this change. Is that okay?
I don't think we need to apply working group process there.
Okay, cool. Let's move on. Okay, this is a bigger one, so strap in. I'm just kidding. Okay, so we have some deployment experience with Draft 9. The way, just to give some reminder, the way aggregation works is a leader picks a subset of reports it wants to aggregate for the batch, and it sends those in an HTTP request, and it in its response, the helper completes aggregation. So actually, How many rounds is required depends on the VDAF, but for now, let's just pretend there's just one round. It's PRIO, for example. So the leader sends a put request, like run this aggregation job. The helper replies with, I've aggregated these, I've rejected these, and we're done. So this step requires a couple of things that might be surprising for new implementers. First of all, the VDAF preparation work. This is like the work that you're doing to do input validation for each report. That's, it's cheap, but if you have a job of like 1,000, then you really benefit from parallelism. But in some situations, for some users, this might not be possible. So here we have a CPU constraint that we really can't ignore. We also have a strong requirement for consistency. So the helper is expected to commit the state change to its long-term storage before it can reply. So this is like write the aggregate share to a database, write the set of report IDs that for anti-replay. So this creates resource contention, especially if you have a large number of aggregation jobs running in parallel. Because really, this is what we want to be able to do. We want to be able to, the leader to just horizontally scale by just spouting out a bunch of aggregation jobs for the same task, for the same batch simultaneously, and expect the helper to keep up. There are, so our P99 in our first kind of experimental deployment was like 10 seconds, which is really like not very good. But we're interacting with a database. And sometimes that database gets slow, especially if, in my company situation, it's a very multi-tenant environment. We don't always have the CPU and or sort of back-end communication resources that are required to resolve the request at the given time. So I think the other people have had a very similar experience. We want basically to give the helper some time to do the work it needs to do to respond to the request. So the proposal is to allow the helper to process jobs asynchronously. So basically, the helper gets to respond to a put with a 201 created, and then immediately after parsing the request and doing some little bit of pre-processing, and then the expectation of the leader is to send a GET request to get the result. And so this is kind of like polling, very much like how collection works today. So this is an optional behavior. The helper is allowed to respond with the actual payload or not. It's up to the helper. So so we have a PR for this. This has gotten a lot of feedback from, I would say, a pretty big group of core people. I wanted to hear if there was any objections to taking this change. Anybody have concerns about this? I see someone in the queue.
Watson Lad Akamai. I'm not quite sure I follow what's being contended on. Is it just that you might need to take a while at the end to say, okay, these reports have never been used before? I'm wondering if making it asynchronous, yeah, it lets you hide that latency. I'm not, and retry, not sure it necessarily gets you the results any faster. Maybe the right solution is, as you're going through the reports, say, okay, we're never using this report again.
I'll let Noah's in the queue, maybe has a response.
Yep. So there we go. Now, to remove myself from the queue and remove myself.
Audio is
Your mic's way too loud.
Is that better? Is this better, or
A little bit louder.
there we go?
Yep, good.
Perfect. All right. So what the issue here fundamentally is that the replay checks in particular basically require a serialized transaction across all basically on every request for a new aggregate job. And like that is like under like most architectures, that is actually fairly expensive to do just in general. Like serialized transactions are expensive with like are just basically just generally expensive. But especially what we found is for like those running networks that are distributed across sites or across geographic regions and that are trying to like receive aggregate jobs across us sites, like this is particularly troublesome, not just from like not necessarily so much from a compute perspective as it is from like an availability perspective and like handling network partitions and things like that. This gets much easier if you can, like if for example all you have to do in response to getting a new aggregation job is just queuing it for eventual processing somewhere, because like the like operational considerations basically with these serialized transactions, we can shard them a fair bit and like trade some availability, since now like any shard going down could break things. But like that moves the failure risk out of the critical path. Watson, does that answer your question?
I think I think it does. It's basically you're saying that because you had to respond while the leader's still on the line to say that yes, all these things you sent us were good, you don't have enough time to do this big transaction. We can discuss more on the list. I'm not quite sure I still get by the, but thanks for the explanation.
Yep. That's that was all I really had to say, was just responding to that.
So Martin Thompson, I'm wondering if we could engage with Watson's suggestion, which was to suggest that the helper take the tasks, maybe on the assumption that the leader has performed already some amount of replay detection and whatnot, so that in most cases you won't have to do anything further beyond that point, but then develop an exceptional process for identifying those records that were indeed replays according to the helper's understanding of that, and having a way to strike them from the register.
So we looked at this, that we had, yeah, so I think this, if I understand the suggestion, it's implement eventual consistency by allowing the helper to reject replays at some point before collection is finished. Does that sound like the suggestion? So I think one downside we found of this approach is it requires the helper to start storing individual reports. Whereas today, and I believe even with this PR, it can store just aggregates of things that it has committed to aggregating.
Yeah. So I'm not suggesting that that's necessarily the case either. So if you look at this process here, if that 201 created was a 200 OK, and if the failure mode of this scenario invoked a new process rather than the success mode invoking a new process, then we have something that I think is much closer to what I was suggesting than what you described. Does that make sense?
Yeah, so it's something like if I don't think I could finish this in time, just abort and then retry?
No. So it is the leader sends a job to the helper. The helper says, okay, I've got it. And that's all the 200 response would be in that case. It then proceeds to do the processing that it would do, which is checking for replays. And then if that's successful, it adds to the aggregate. No more action on that side. However, if it detects a replay, it is the responsibility then of the helper to say to the leader, hey, you sent me this, it's a replay.
Yeah, when does it do that?
When it detects that something is a replay.
So
which is
the helper's
in the same
a server,
timeframe.
so it has to do that in response to some HTTP request, right?
Right, okay.
So which
So
request?
are you suggesting that it does this via like a webhook or via like another input that can be pulled?
Well, Noah's question is a good one. Yes, why not? Or you could have some regular process whereby the leader checks in with the helpers to say, look, have you got anything that's broken? Let me know about it. Now, of course, that's problematic from the leader's perspective potentially, because the leader may have done the aggregation as well.
So this creates, if I understand the proposal, it creates the requirement that both parties store individual reports until the batch is finally collected.
Right, which is why I don't like this replay design, anti-replay design at all. Maybe we should be talking about that instead.
I actually don't see how this is too different from the current async proposal, where like the leader effectively polls after that to see like what the status of that request was.
Yeah, the difference might be that you can batch in the other case, where you could say in the reports that I've submitted to you in the last half hour, should I go and scrub any of them for replays? Because in most cases the answer will be nope, and we carry on, right?
Yeah, so I think there's always an option to like, I'm only going to do replay protection, guarantee replay protection for the last 30 minutes. Beyond that 30-minute window, you just drop the report on the floor because you don't know whether or not it's replayed. And that implementation is available to both parties. The requirement is that, the requirement since the beginning has been no report is ever replayed. No individual report. Okay. So I guess if someone, I guess we'll have to hold off on merging this. Martin, if you want to talk about this a little bit more. So yeah, I guess we'll wait to hear from you. Maybe if there's time, we can talk about a little bit more. Okay, does anybody want to either raise their hand and, I'd like to hear from more people. Does anybody feel strongly that this is the only way this change needs to happen? No?
I am pretty strongly in favor of this happening. I think we need to if we need to either get rid of these sort of like serialized transaction requirements, or if we're going to, or we have to keep them, we need to at the very least get them out of the critical path and get them into somewhere where they can be like nicely and easily retried over time.
I'm not sure I understood that actually. Did anybody else get that?
Do you want me to was my mic quality a bit off, or?
Sorry, I didn't understand the question. It's hard to hear you, Noah.
Is this better?
A little bit.
How about this?
It's hard to tell until you say it. Maybe speak a little bit slower.
Okay. All right. How easy is this? How easy or hard is this to
Turn down your
follow?
gain if you can. Yeah, it's just the room. You're very bouncy, so it's hard to hear everything.
All right. I'm going to switch to another headset and rejoin.
Tim?
Thanks. For whatever it's worth, curiously, we can hear Noah pretty well remotely. I'm not sure maybe there's something up with the sound system in the room. In any case, yeah, as Martin notes in the chat, room acoustics are terrible. Okay, in any case, excuse me. Right, okay, so Martin brings up a lot of interesting points. I think we need to take a hard look at anti-replay stuff. However, I think that this change is, change to make asynchronous, make aggregation jobs asynchronous is a good one regardless, for the reasons that Noah was just trying to explain to us, which is that it removes serializable transactions from the hot path of the protocol. Basically, my thinking is that even if we go do like smarter anti-replay stuff that Martin is sketching out, that this change is probably still a good idea.
Yeah, there's not just the replay protection. There's also the CPU stuff you have to do. There's CPU bound work to do as well. Yeah,
and also I want to sort of double down on the point that you made, Chris, earlier, which is that if we're not careful about how we articulate anti-replay, and particularly the recovery mechanisms, then you easily end up with cases where, yeah, the helper has to store individual reports or individual prepared reports, and that makes the storage requirements for the helper like vastly bigger than they are now, which is a problem on its own, but especially given that a design goal throughout DAP has been to make the operational requirements on the helper lower because we want it to be relatively cheap. I mean, DAP is pretty expensive no matter what, but we want the helper to be relatively cheap and easy to run.
We got a queue.
Amir? We don't hear you.
It would help if I unmuted myself. Sorry. I'm Amir with ISRG. I actually wrote this PR. I wanted to clarify that as written, and I think what is already true even before this PR, that there is still one arguably small requirement of a serializable transaction for the aggregation job ID. Because imagine, if you will, two simultaneous requests come in for the same aggregation job ID, but different request bodies. The way this PR is written, you have to be able to detect whether a duplicate request is coming in, because otherwise it becomes ambiguous as to what request that the subsequent GET request should actually respond to. So more broadly, I think if we're trying to solve the problem of moving all serializable work out of the hot path, I think we might have to go design a little bit more, and maybe to what Martin was saying. And then even broader than that, speaking for myself and a little bit of who I work for, there's no urgent need for us to adopt this. If we need to go and iterate on it more, no big deal.
Noah?
Yep. Is my audio better this time?
Yes.
All right, perfect. So, what I was trying to say earlier is that I think we should. I am strongly in favor of this. I am with Amir that we should also, if we're doing this, we should also try and get rid though of the other serialized transactions that are required. So we should revisit the aggregation job check, for example, and how that works. But yeah, no, I'm pretty strongly in favor of this and getting anything that has to be serialized out of the critical path. And that said, if we can find other ways that to make this more eventually consistent, then I'm all ears to those proposals as well.
Martin Thompson, if people will indulge me, I'd like to up-level just a little bit. An anti-replay design that works without having to track every single job is one that is the time window one that I talked about previously. If there is a span of time bound to the task, then things that are in that window will be accepted. Oh no, that's not right. Sorry, I'll go back and put my brain back in again, and we'll see if we can go.
All right.
Ben Schwartz, as individual participant, these two options seem like different HTTP API bindings of equivalent functionality. I feel like I could write an HTTP frontend that converted one into the other statelessly without ever touching, well, okay, not quite statelessly, but without touching the state that we're worried about here. So I think it might be helpful to disentangle that a little bit and talk about the maybe changes in dependencies between different kinds of information that you're storing separately from the question of how you actually represent that in the HTTP API. Because, for example, there's no obligation that the leader only has a single HTTP request open to the helper at any given time. So all of these things are highly parallelizable.
Yes. So the parallelism is what leads to resource contention. So imagine you've sharded your database, but you have multiple aggregation jobs hitting the same shard at once. You're queuing a bunch of work against one shard. And the problem, and it's an operational problem, is that queue gets so full that you can't handle requests in a timely manner, and there are impacts, observable impacts in other aspects of your system.
So that I think that's exactly the same here, right? You create this thing, and if you have a bunch of these puts all at once, then you'll build up a queue, and it'll take some time to drain that queue. And in the meantime, these gets that are polling are going to keep returning some sort of wait state. I think it's equivalent. The way in which it's not equivalent is if you have NAT bindings and HTTP middleware that doesn't play well with HTTP requests that take 30 seconds to come back.
So that's exactly, So that's exactly my organization's problem. We're bad at holding requests open for a long period of time, because the lifetime of a request is generally like a second tops.
Sure. I think that's a fine sort of HTTP API design question of what is a reasonable limit on how long a client should expect to wait in our system.
Yeah. So is that in favor, or what outcome would you like to see for this PR, if any?
So I view that as kind of a trivial question. There's really, it's not difficult to write an HTTP API that avoids those long delays, and we should just do that and disentangle that as much as possible from the question of intertask dependencies that and deeper questions about how the database works.
So I would love to see that suggestion put up in a PR. All right. Okay, I'm just going to take a note and then we'll move on. All right. That's the one that I was hoping we could solve today, but that's how it goes. Oops, I accidentally stopped sharing. I'm sorry. This is like my 10th IETF. I should be better than this. Okay, moving on to hopefully one that's a little bit easier, although I don't think the professional IETFers in the room are going to like how we want to resolve this. So there is an ambiguity in our document the way we use TLS representation language. So we will write something like what is shown on the yellow highlighted line there. We say, like, here is the struct, like, so basically the text that precedes this is the party constructs a message with this format, and we're saying, like, set this value to 2, the first field to 2, and then report ID, report share error, these are set, these are like implied by surrounding text. This is, this syntax is used in 8446 to indicate a constant. This field does not change, and the reason for this is because TLS 1.3 had to be written in a way that is backwards compatible with TLS 1.2. So it's a historical artifact that needed to be spelled out in 8446. So we're overloading this, which is a problem. There's kind of 2 ways you can resolve this. One is we just don't write text in this awkward way where it's like convenient to do this. The simpler, hackier change is to just modify TLS representation language, and we do so as follows. We add the word variant after the word struct, and this indicates that we're specifying like a more specific variant of this struct here. So what do people think about merging this? Does anybody object? Yeah, let's hear it.
This is an editorial question, and it's up to you. How do you want to present your protocol? I don't think we need to discuss it here.
Cool. Any other opinions? If there's no Watson, go ahead.
I would nitpick struct variant. Maybe variant is all you need.
Okay. We'll take that suggestion unless there's unless Tim, who wrote this PR, doesn't like it. Tim, do you want to say something?
Yeah, well, 1, I support this change because I wrote it. 2, actually, I quite like Watson's suggestion. Indeed, we don't need both struct and variant. If anything, really, if we were going like deep on this, we would want to like make the notion of an enum more powerful. Like that's where the notion of variant comes from, is because where we use this, typically we're describing a variant of an enumeration. Anyway, long story short, I think we should take Watson's suggestion. I will tack a commit onto the PR in question to achieve that.
Okay. All right, moving on. We're going to merge that. That's the decision there. Okay, so this one, I was hoping Chris Wood would be in the room. Okay. Okay, so so context. Oh, Tim, do you want to interrupt?
No, I just want to get in queue to say something about this after you've finished explaining it. Though if you want me to, I can speak to the slide.
Okay, I'm just going to continue. Today there is a feature of the protocol that allows you to configure tasks, configure per task HPKE configurations. So as a reminder, HPKE is used to protect report shares in transit to each of the aggregators. So when I'm uploading a report, I first shard, I do the VDAF-shard step, and then I encrypt each input share to the intended recipient. And that way they're confidential in transit. So what key do we use? This is obtained by hitting this endpoint called HPKE config that is specified by each of the aggregators. Yes. So today you can specify a task ID parameter in your request, and that will integrate to the server. If you have a particular HPKE config you want to use for this task, let me know and I'll use that. And this is, so this is meant to provide key separation. So this is slightly problematic for applications that might need anonymity. So imagine you are running DApp over OHTTP, which is turning out to be a common deployment scenario. Aggregators know basically what task a client is participating in, and that might invalidate some of your security properties. So there's and just as another note, I'm not aware of an implementation that is using this feature today. So there's two ways we can resolve this. One is add more security consideration text describing the scenario and what to do in that scenario, or we just nix it because we haven't needed it so far. So the PR removes this task ID parameter and basically forces you to use the same set of HPKE configs for a given endpoint. So does anybody have opinions about whether we should take this or not? Go ahead, Tim, you're still in the queue.
Thanks. Okay, so I think Chris explained what this change is about. And another key motivation in our analysis, like divvy up that is, or ISRG, was that when you do DApp in conjunction with OHTTP, which we think is going to end up being a quite popular configuration, you end up very strongly wanting what we call global HPKE configs or non-task specific HPKE configs. Because per task HPKE configs is a privacy leak. It reveals which clients are going to participate in which tasks. Additionally, there's TaskProv, the sort of automated client-driven task provisioning protocol, which is not adopted, I don't think, but it is a working, whatever, it's an idea in the working group. TaskProv also basically forces you to do global HPKE keys because the client doesn't yet know what the task will be when it's generating reports. Okay, so but the one nuance I wanted to bring here, having like written this change and still on balance supporting it, is that the real motivation for why I did this was that I saw an opportunity to take some text and like some conditionals out of this protocol. And I feel like, simplicity is always a good principle, a good North Star to follow. But when I went and actually made the change, I realized like this doesn't actually delete that much text. And it's also like extremely easy for implementations to just not do per task HPKE keys. Point being, I don't think it costs us very much to continue to allow per task HPKE configs in DApp. So I think that should be borne in mind when we consider whether or not to take this.
Cool, thanks, Tim. Just one clarifying thing, TaskProv is not a working group draft.
Yeah, sorry.
Does anybody else have have anything they want to say? I think I've heard one opinion offline about this, agreeing with Tim that this is not necessary to take. Does anybody object? The decision right now is do not merge. Nick, go ahead. We're short on time and we do have one more to talk about, but this is more important than the next one.
I'm also interested in the next one, but it seems like a privacy improvement. So if it's also simpler, that would be a vote of support for taking it.
Thanks. Go ahead, Amir.
I support taking it because I'm not sure that has anybody come up with a tangible use case for the task ID parameter that isn't covered by a global key. I don't believe that's the case, so I would be in favor of striking it.
Cool. Thank you. Martin, you're next.
Yeah, Martin Thompson, it seems like this can go. And I'm not hearing anything in favor of keeping it. So in the spirit of making everything better, privacy, simplicity, making it easier to deploy, cut it.
All right. All right. I think Tim and I will talk offline, but if I could convince him, I think we'll merge. All right. Next one, and this is the last one. Okay.
Sorry, Chris, before you move on, may I?
Oh, go ahead, Tim. Sorry.
You guys not see the? Yeah. To be clear, as much as I argued like against the previous change, I think we should take it on balance. So I suspect.
Okay.
All right, let's move on to the next one.
All right, merge. Great. Okay. So there have been some suggestions from about it might be useful in certain circumstances to add versioning to the content type. So the content type is a field of the media of the HTTP request that tells you basically how do I parse this message, and so the media type has to match like the type of message that's being transmitted. And because we are making breaking changes in the protocol sometimes, it might be useful to actually, there's other ways of doing versioning potentially, but some have asked for being able to do versioning this way. So you might indicate the draft number and or something like that. So this is a may in the draft. This is like may use it this way. Tim has noted in the past that this is something that HTTP semantics already lets you do. So it may not be necessary to have normative text at all about this. In any case, this would be deleted before RFC because the text is specifically about drafts. Noting that if we do have DAT v2 post RFC, we'll have to update the media types anyway for that new draft. So does anybody have opinions here? Tim?
Yeah, I don't think we need this for the reasons you noted. For the other reason that like this is text that we would add, and then it comes in the proposed change. It comes with a note that says delete this when we go to RFC, which we hope, that's me knocking on wood, will be soon anyway. So I don't see why we would take text that we plan to delete imminently. And finally, the concrete like proposal for how to do this versioning that's in the change is to add I forget what it's called, but like you put a semicolon at the end of the media type, and then you add some like version equals this. Which is fine, but yeah, like HTTP already allows you to do this. I don't think it's fruitful for a protocol that is built on top of HTTP, like explicitly and with a normative reference, to enumerate the things from HTTP that you're allowed to do. So yeah, I mean, I don't think we should take this.
Okay. Do we have time to drain the queue?
Yep.
Cool.
Queue is open. Suman? We don't see you, Suman. Oh, now we see you. We don't hear you.
I'm sorry. First time IETF.
We can
I'm
hear.
just curious, what HTTP is providing out of the box without having something like this. I understand that major dApp versions can have a different MIME types altogether, but I just heard some comments about HTTP use this out of the box. So just wanted to understand bit better.
I'm not sure I understood you, Suman.
I think that was directed at me, so I'll respond to that. Yeah, I mean, the specific feature is the ability to tack on, again, I forget what it's called, but this is what's proposed in the change, right? Is that like at the end of, so the example on the slide is the media type application / dApp aggregation Java.NET request. So you would tack on like a semicolon, and then I think it was like draft dash version equals something, some number, right? So the point is that that syntax of semicolon separated like fields in a media type, that's something HTTP already defines, already lets you do. And like without this change to dApp, any dApp server should already be able to handle those fields. Or like
No, but that's not a standard, right? In the media type, you could pass anything. This here we are explicitly specifying what to pass there.
Well, the change as is doesn't though. Like it just says like, hey, you could go do this, but it doesn't actually instruct applications what to do in the presence of a given version value. So
I think we need to close this topic and move on in the interest of time. So I would encourage the editors to consult with some HTTP experts outside this room who might have some advice on the best way to use content types with draft versions.
Thanks. So what's the next one? I think I'm up next, right?
Yes.
Okay. Oh, do you want to do task prov first or the other one?
Task prov.
Okay. So this one should actually be quick. I think we had like 15 minutes for this, but I guess I said that about the last topic. Okay. So this is a draft that we are seeking adoption on. This specifies an extension to a report extension to the dApp protocol that has a couple of different tasks, a couple of different objectives. The feedback that we've gotten from this from previous IETFs is some people are enthusiastic about one of them and then not the other. So the feedback has been to split it up. So that's what we've done. So let me quickly go through the goals. The first goal of this draft is what we call task binding. So executing a dApp task requires each party in the protocol to agree on the task configuration. So there's many parameters that everyone needs to agree on, like the batch size, which VDAF to execute, what is the query type, well, batch mode we'll now start using to call it, and things like this that matter to execution. There's no mechanism that tells you that everyone actually agrees on this. So what we're trying to accomplish with this extension is when a client uses this extension, the aggregators who support this extension will check that the client and that aggregator agree on the parameters. And this is accomplished simply by specifying a serialization of the task configuration and deriving the task ID with it. So what the aggregator does is, I see this report extension. If I don't recognize it, I reject the report. That's already, that's the semantics of the protocol today. If I do recognize it, what I do is I make sure the task ID matches the task config. And if they agree, then I accept it, or I drop it right there. So yeah, so basically what this is supposed to do is say, like, if I've executed the task appropriately, it's because I agreed on the parameters. Or rather, if I don't agree on the parameters, then I'm not going to execute. Contrapositive. Anyway, you know what I mean. Okay. Another goal for this draft is actually provisioning a task. So what the draft says is the task is configured out of band. There are these parameters that all parties need to agree on. We don't tell you how they agree on them. So this is what the draft initially did, was specify this mechanism where basically you can advertise the task config in an HTTP header, and you either opt into the task or opt out. If you opt out, then it's basically an abort and the protocol stops. If you opt in, then you have then you're like agreeing to take those parameters and continue processing. So the security considerations for this are the same as the core DApp protocol. We don't intend that this changes. Of course, this is attack surface and we have to account for it. And we've done some things to do just that. The other aspect of this is like how many tasks are you running through your system at any given time. If you have a fixed number of tasks, this is just not necessary. But if the set of tasks is large and maybe changing over time, this can be useful. So I will say we've been experimenting with this. We have this deployed, and we're comfortable using it at least. So whether or not it gets adopted, it's going to get deployed. Okay. So changes to the protocol, mainly to address feedback. The main thing being splitting task binding and provisioning into two different sections. Provisioning is completely optional. Task binding, and we've actually renamed the extension to DApp task bind instead of DApp task prob. And yeah, what else did I want to say about that? And we've reduced the advertisement rate, so the client doesn't have to send it with every request. That was a good observation. We took that, and we also then, as individual, pointed out some potential privacy concerns with fingerprinting, and we kind of addressed that by acknowledging it because there's not anything we can do about it, and we're not certain the risk is that high anyway. So yeah, happy to talk about any of these things. We want to ask for adoption. We think this is ready to go. There's a few changes we can make afterwards. One of them might be just rip out the task provisioning bit section completely. We're open to that. So it's just task binding. But yeah, what are people's thoughts on this? Anything else you want to see before we adopt this?
It would be great to hear some comments on this draft because the authors are pursuing adoption in the working group. Okay, great. We have some commenters.
I'll just go ahead. So I think I agree with Chris in the sense, particularly in the point that this has been deployed and implemented and deployed in a couple places now. So there might be merit in adopting it in this working group for that reason, just so we can all work together on producing the best specification of it that we can.
Nick Doty, CDT. I believe that I'm generally supportive of in-band task provisioning because it provides an opportunity for interoperability rather than sort of out-of-band proprietary. You have to already have just some existing agreement between the client and the aggregators. But also it seems like it gives us an opportunity to address the transparency question for the user. I know it's not the only way to address transparency, but it does seem like a good mechanism to give the user through their client an opportunity to investigate the properties of a task, decide whether or not to participate, and that seems like a good approach to the sort of privacy and ethics of participation. And even if it can be done in other ways, it would be good to standardize one way to do it.
Tim, you're still in the queue?
I am, or I'm in the queue again to respond to Nick. in that it should be noted that TaskProv doesn't resolve the issue of needing a pre-existing relationship and arrangement particularly between like aggregators, because there are at least like some secrets that you have to share and other parameters that you have to share between participants before a task gets provisioned. So this like what we have here doesn't get us to a world where like anybody can just rock up to any aggregator and start doing DApp like completely seamlessly. You still probably have to establish business relationships. I also think we should be incredibly careful about talking about transparency because like, I'm sorry, this is not certificate transparency. It doesn't do the same things. It isn't like it doesn't provide the same security guarantees but other transparency solutions do. So let's be very, very careful about like gesturing at those concepts.
Yeah. So transparency, but I think, yeah, I think that's absolutely worth calling out. It's not like it's, you know, there's a couple things. First of all, Tim's right. There still has to be some pre-existing relationship between the aggregators, between the collector and the leader, between the leader and the what do you call them, the clients, and some system has to arrange for that communication, and that's not fully specified here. There, in particular, like this, there is the shared secret from which we derive the VDAF verification key that we use for a given task. But I do think we improve like the state of affairs. Like the client gets to decide if it likes the minimum batch size, and I think that's a good thing. So it's not transparency in the broader sense of IETF, but it's better if, yeah, it's better. The client knows more about what's going on, at least if they can inspect their device.
So Chris, is there a poll that you would like to run in the room for this draft today?
Sure. Yeah. 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 Sure.
We could run a poll to ask if people have read the draft. We could run a poll to see if people would like to adopt the draft. Do you have any thoughts on what sort of poll you'd like to see?
I'd like to know who's yeah. I'd like to know who's read the draft. Yeah.
Okay. Appreciate you. Okay. So I've opened a poll. Please open your on-site tool, or if you're off-site, please note the button to switch over to the poll view. If you haven't used the QR code to connect your on-site tool to the room, this is a great time to do that. It is obligatory. And we'll puzzle over later what it means to not have an opinion about whether one has reviewed the TaskProv proposal. I'm going to give 15 more seconds for that. All right. So I think it would be great if a few more people could review this draft. And I do think that we're going to, I think we should expect to see a call for adoption in the near future.
Thanks. All right. One more for me, and then and I'll make this really, really quick. This is just an idea I want to put in people's heads and think about. Okay. So I think that one of our jobs as a working group at IETF is, especially one that is working on fancy crypto, is to help direct academic research towards problems that matter to us. So there is a couple recent papers that that basically add some efficiency, or at least like shift around some things in VDAF execution that lead to different trade-offs for like a protocol that uses it. So I want to talk if I want to see from the room, if I just basically want to have an on-the-record conversation of, is this something that academics should be pursuing? So yeah, let's get into it. So basically today, the way processing works in a VDAF is we are doing some processing per report. So this is the input validation thing. We call it preparation for reasons that we don't need to get into. But the idea is that I'm running, so this is on, like, think of this as an HTTP request, an aggregation job. For each of a set of reports, I do some computation and I send the result of that computation to the helper. The helper does basically the same computation and produces a response. And at the time it's produced a response, it knows whether each of these reports is valid. And then there's one more message to send to the server, and the server will compute the same thing. So this is kind of an abstraction around like the zero knowledge proof thing that we're running in Prio. So we do this per report. And then, like for each report, if it's valid, we reject it. If it's invalid, we reject it. So there's a couple new papers that allow this process to be batched. So basically, for a sequence of reports, I can do the same thing. I produce this value called a tag that applies to all of the reports in the aggregation job. The helper produces the same thing, and then with these two tags, it decides, is this batch of reports valid? So if all of the reports are valid, then it knows it's valid. If one of them is invalid, it doesn't know which one. There may be more than one. So it's a yes or no, like, is everything good, or is not everything good? So so one paper that does this, like from S&P Security and Privacy this year, Whisper. This is from Henry Corrigan Gibbs, the designer of much of the crypto that we're already using. So they figured out this way to make a fully linear proof system. This is the thing that we use in Prio, what they call silently verifiable. And this basically allows this batching thing to happen. And I'll skip the details of how exactly it works. What we end up with here is we have the same bandwidth overall, except the client is going to be sending more bits than the aggregator. So during aggregation, we end up sending substantially less. So and instead of the leader sending that to the helper, the client sends it to the aggregators. So we're just shifting around who pays the cost for the bandwidth. Do clients pay the cost for bandwidth, or does the aggregator? And there's another paper that does this similarly and with similar functionality as Poplar. There's a draft PR up that shows how we would incorporate this into DApp. And basically this would be like, if the batch is not valid, then we fall back to per report validation. This is an option for both of these constructions. So the thing is this doesn't have any bandwidth savings for our protocol as it is, and it has to do with the leader upload architecture that we picked back at like IETF 113. If we had gone with split mode, where the client sends a report share to each of the aggregators individually, then we would get this benefit of, again, the communication cost is the same, but the client pays the cost. So the question for everyone is this a desirable property? It has some potential downsides. We have like a denial of service thing that we have to engineer around, but some parties might be able to make this work. So I'd like to hear what people think of this feature. You have 5 seconds.
Tim?
Thank you. Well, I have no more seconds left. Oh, sorry. Okay. I think Martin Thompson elsewhere has made the point that another important trade-off to be weighed here is moving work between the servers and the clients. Like, we have to be mindful of the fact that there's a lot of clients out there, right? And if we push more compute work into them, like we're using up people's battery life and we're burning a lot of carbon, and yeah, we have to be making responsible use of people's CPU time on their phones and on their laptops and so on. Okay, otherwise, I like the degree to which, like, it's cool the degree to which this working group engages with, like, what did Chris call it? Fancy crypto, or, you know, cutting edge stuff from papers that have just been published. Like, that's good. But one of my takeaways from the DApp process has been that we really should, I think we should be motivated by, like, concrete, not quite industry, but like industry use cases more so than, you know, there's a paper out there. So rather than speculate that like maybe somebody has a use case for this, I think the use cases need to come first before the working group commits time and, you know, protocol text to looking at a problem.
Totally agree. I'm not suggesting we work on this. This is the point of this is there are academics that are spending time on this problem, and are they spending the time on the right problem? That's the thing that I want to ask. Because if they're not, we should tell them.
Sometimes silence is an answer. Let's move to the next topic.
While Ben's getting up and getting situated, is there anyone willing to take over notes for this session? Because I feel like I might have some things to add.
Watson has reiterated his volunteering to help out with note-taking. Thank you again, Watson. Yeah. So, yeah. Looks good.
All right. This is Ben Case at Meta, and joined by Martin and Alex here in the room, and some other folks from our teams that have contributed to what we'll talk about. So we'll talk about binomial DP noise generation in MPC, and a little bit of...
You're going to need to be closer to the microphone.
Thank you. All right, so as I was saying, Ben Case from Meta, and joined here by Martin and Alex. We'll talk about DP noise generation in MPC, and also mention a couple of other topics that may be of interest to this group. So Martin shared on the, see if I can get this remote thing to work here. Yeah, on the email chain, 3 new drafts that we would like to see this group express interest or feedback on. The first one is the one that we'll talk in most depth about today, which is about generating central DP noise inside of MPC using a binomial mechanism. And then the other 2 are related to doing 3-party honest majority MPC. So I think in the last IETF in Australia, Ben Savage was here also from Meta, and he and Martin sort of gave a little bit of an overview of this direction of 3-party MPC. And then another tool in this box is pseudorandom secret sharing, which is a way for sort of MPC parties to sort of sample sort of a shared secret state. So we're going to talk most about the first one, and maybe there can be some discussion as well toward the end about, you know, this group's interest in sort of continuing some of these things after DApp. I think the first one is potentially interesting in even the DApp setting of 2 parties. The other 3 are, or the other 2 are perhaps more future. All right, so as I said, we'll spend most of the time talking about the DP noise in MPC. And first, we'll kind of talk a little bit about the motivation for this. So I think the motivation for DP itself is pretty clear. Like, we want, you know, DP can help you a lot with output privacy. But then the question is, well, why generate the DP noise in MPC? There are other approaches. The most natural baseline would be for each helper party or worker to add DP noise independently. And as we'll see, that sort of gives you a baseline for how much DP noise is added, but it it tends to be more than what is sort of ideal. Another sort of alternate approach here to sampling in the MPC would be having clients add local noise and shuffle. That approach has some benefits as well, but it also has a trade-off that it sort of the noise can be dependent on the size of the query quite heavily, whereas this approach can tend to separate the two. Then the other question you might want to motivate is why binomial noise. If you're familiar with the DP literature, normally people would sample from a Laplacian or a Gaussian. And I guess the approach here is more of a pragmatic one. Like we would like to use something which is as close to the Gaussian as we could, but binomials are simple and they're also relatively simple to generate inside of MPC. And at least for a lot of common parameters, they might give us a meaningful improvement that we're happy enough with. So we'll at least start here. All right, so talking a little bit about the binomial DP mechanism itself. So suppose you have a function here that computes something on a private database D, and it maps it to the integers. In MPC, what you would do here is you would sample X from a binomial NP distribution, and then you would output the function plus the noise. The recipient is going to get that output. They'll get it from the MPC, so they'll have to recombine shares to find out what the actual result is. But then after that, they will also subtract off the mean of the binomial to have an unbiased estimate of the computation on the database. Okay, this is the basic protocol or mechanism here. You can make it a little bit more involved here, where the function D the function F is sort of D-dimensional outputs. And so here, of course, you're sampling, D IID samples from your binomial and adding one to each component. You can also add this additional factor here, S. This is a scaling parameter. There's a paper, I think I'll come to it in a slide, by some researchers at Google that sort of analyzes a lot of the different parameters for binomials in the DP context. And this scaling parameter can help you to sort of tune to get a good sort of privacy utility trade-off in more parameter regimes. So then if you're the recipient, you're going to need to subtract off your mean, and then you need to sort of rescale things. So generally here, we're going to be making S small. So S is 1 over some natural number. Okay, you can write it a different way, but I'll skip that. All right. So now the main question that this draft considers, and it's based on this 2018 paper here, is if you want to get approximate DP, which is given some epsilon and delta, you define your privacy with those. How should I set the parameters of my binomial? What is n and what is p? So that's most of what this draft currently looks at. Thankfully for p, the answer is simple. Set it equal to 1/2. That's optimal for some reasons the paper discusses, but it makes for a nice feature for us in the fact that sampling uniform random bits is also the easiest thing to do in MPC as a coin flip protocol. Determining n from your epsilon and delta is a bit more of an involved process. There are two constraints, one that depends only on delta, the other one that depends on both epsilon and delta. And that one is a little bit more heavily dependent on the epsilon factor than the delta. And basically what you need to do is do some calculation to find the smallest n that satisfies both constraints simultaneously. These are the constraints, and the paper discusses them in more depth there. I won't get into the details. You can see it's a little bit involved in the math. If you're familiar with Laplacians, normally you look at the L1 sensitivity of your function. Gaussians, you look at the L2 sensitivity of your function. If you're looking at binomial noise, you have to consider both the L1, the L2, and the L infinity sensitivities of your function to sort of properly get your epsilon delta parameters set. Okay, but needless to say that these are just some complicated equations, but we can solve them either a little bit analytically with a quadratic and n, or as I did when I first just started trying to implement this, is just do a binary search to find the smallest n that satisfies both. And once you've determined that, then you'll know how you need to set up your sampling. The other sort of parameter here is this, quantization scale. So decreasing your quantization scale is going to reduce your error, but it's going to increase your n. So, and then the n increases the MPC cost. So this is one where you kind of have to play with it a little bit. And right now it's just somewhat of an exploratory process. Maybe we'll have some better analysis in the future that will sort of tell you what you want to do a little bit better here. But basically you want to decrease this as much as possible, subject to your practical MPC cost constraints. So as I mentioned, I think I maybe missed a slide way back or that was just talking about what we need to do here in terms of generating the DP noise here. So once you're, let me just see if I had it. Yeah, misses binomials here. So in an MPC, right, if you're going to sample from a binomial, if you remember, a binomial is just the number of successes in Bernoulli P trials. To do this in MPC, you need two things. First, you need sort of a coin flipping protocol to run these trials, and then you need some way to sum up the values. And if you sum up the values, that will be the number of successes. So it's a pretty straightforward protocol here that allows you to sample binomial noise in MPC. So now moving back to where I was, though, setting the parameters. The thing that you want to try to minimize here is the error that you're introducing into the actual outputs. And so this is where we can start to look at what are the baselines and how can we compare how well we're doing the binomial to other approaches. So in an ideal world, you would like to sample from a single Gaussian distribution that like exactly satisfies your epsilon delta constraints. And you would do this inside of MPC and it would be perfectly generated. Okay, so that would give you sort of like the ideal minimal amount of noise inside of MPC. And there's an error formula for what that is. In the binomial case, you have a different error formula. And the other approaches would be to have error that is added independently by each of the helpers. So if you're in the two-party case, two of your workers add DP noise. If you're in the three-party case, honest majority, all three add noise. In the three-party honest majority setting, you end up with 50% more than is ideal, so more than this like single Gaussian case. Because in honest majority, if you think about it, every party is going to add sort of 50% of what noise is sort of needed in the end, so that every two of them are trusted to at least add their noise. You end up with 100% of what you actually need to guarantee. But that means that for your typical output party that receives the outputs, they've actually had noise added by all three parties. So you get sort of 150% of sort of the desired noise. So 50% more than what's ideal. In the two-party case, you end up with twice as much as is ideal because each party needs to assume that the other party might not add their noise. So each party needs to add it fully. So these are sort of our baselines. How can we improve upon 50%? How can we improve upon 100%? And how can we do that in the binomial? All right, so I have some tables of parameters here for different epsilons, deltas, the sensitivities, different dimensions, different scaling parameter, and that gives you what's this n. Okay, so I think that the two columns of most interest here are probably the ones on the right. N is like how many samples do you have to add together inside your MPC system to achieve the percent here of error that's worse than the ideal setting. Okay, so on this side, I'm targeting n's that are less than 1 million here. So I think the main takeaway is that for a variety of different epsilon delta parameters that maybe you're interested in for your DP system, if you sample around 200, 300,000 Bernoulli samples and you add them up, you can bring your sort of worst case error down from like 100% of what it would be if you did it sort of with two parties down to around 50%. So you can sort of like improve your privacy utility performance by around 2x by sampling 200 or 300,000 bits. All right, the next table looks at sort of a more generous sort of allowance for n. So here we look for n's up to 10 million here, and that sort of for a variety of different, epsilon deltas, you can see allows you to sort of bring your error down to around, 10% kind of ballpark. Okay, so in, say, for example, the 3-party setting where you're trying to improve upon a baseline which was already 50% worse than the ideal setting, you would need to probably be somewhere on this slide here in the 3 parties, where you're trying to sample, a couple million bits to sort of bring your error down to about from 50% to 10%. Okay, and then the next slide is a bit more a more aggressive setting for n. Maybe if you're trying to support some really large queries to begin with, where you're able to sample, up to 100 million binomial samples and add them up. And this is where you start to be able to get your error down to pretty close to the ideal, 2 or 3% worse than what you would ideally have. Okay, but obviously, the cost is going to scale with n. That will depend a little bit on your MPC system, and sort of may depend a little bit on sort of what you want to add overload to the base query itself. So this is kind of a summary there. In the 2-party setting, if you want to improve some like 100% and down to 50% worse than the ideal, you need your n to be approximately 200,000 or 300,000. If you want to improve upon the 3-party baseline, 50% to 10%, you need probably n around 1 to 10 million. If you want to improve further, you're going to need n to be up to 100 million. All right. So one thing you may note on some of these tables of parameters here, if you look really closely, is that we sort of lack really small epsilon deltas with large sensitivities. So that's a harder sort of parameter setting to support. We're kind of do a little bit of future work to try and see if there are other ways to scale. When you're trying to go to those parameters, the scaling parameter doesn't really help you. The paper only analyzes a scaling parameter which is like less than 1. So there may be some future work that we can do to sort of improve supporting sort of those types of parameters. So as of course, I'm sure you'd be interested, like how much is this going to cost? So in the 3-party honest majority setting, so this would be the setting that these other drafts talk about, where we do honest majority replicated MPC. Similar to what we have built for IPA in the W3C, we implement this and we sample 256 samples in parallel. So this would be as if your dimension is 256. So think about like you have a histogram with 256 buckets and you want to generate noise for them all simultaneously and adding the same amount of noise to each bin. 1 million sort of binomial samples is going to cost you about 95 megabytes of bandwidth. And the latency is around 3 minutes on our current implementation. Go to 10 million, it sort of scales up roughly linear. So it's going to cost you around about a gig to do 10 million in bandwidth and more around 30 minutes for the latency. It just sort of goes up linearly from there. So I think the bandwidth expense here is, I think, manageable. I think the latency we still feel is high. And we have some future work with a different aggregation protocol that would hopefully will hopefully improve the latency here. So some of the things that we're continuing to work on for this is work to improve the analysis for small epsilons and large sensitivity parameters. As I mentioned, that's just like a harder sort of parameter space to support. It's also maybe interesting to just sort of get feedback from the group on which parameter regimes might be most interesting to support, and like how large a sensitivity do we actually need might be an interesting sort of piece of feedback. Yeah.
Now or
sure. Go for it.
So I've been thinking about like fairly large ranges of sensitivities lately, but like initially, like we don't have to go crazy. There's a lot of use cases that we have that are just like histograms.
Yeah, I think that's one thing we have seen is that for a lot of queries, especially large scale ones, counting is very common. So counting queries are at least a good place to start there with low sensitivity. As I mentioned, the other thing that we are still working on a little bit here is the 3-party aggregation that would hopefully decrease the latency some here. And then as this draft here is, we have some work in there to sort of sketch out, this is how you do it in the 3-party setting, this is how you would do it in other settings. But the draft is currently sort of empty, and how would you do this in a two-party setting? Okay, how would you initialize or instantiate the MPC to sort of sample and add up your bits in the two-party setting? So this is an area in particular where help is welcome, especially if folks find this to be interesting in the DApp setting and would like to explore this. Definitely, sort of please contribute in this direction. There's been some ideas that have been discussed to use a OT in this direction, but plenty of work to do here. And then the other thing I think that we'll just consider to continue to look at is, this binomial sort of supplies us one way of doing central DP noise. There are other ways that you could approach this in DP that would be, more involved circuits. And, we can see if those would improve our binomials. At least binomials here gives us another good baseline to have. Okay, let me just stop for any more questions on the DP binomial draft for now. And Martin, if you have anything to add, go ahead too.
Watson, Ladd, Akamai, very interesting work. I wonder if there might not be, there's a whole literature out there on MPC for various evaluations. Not sure that at the sizes, there isn't some way to get that down or the performance down, just applying stuff we know. Will be interesting to see how expensive is evaluating Gaussian really.
Yeah, I agree. It would be nice to have these sizes down a bit more in the total cost. And so I think, yeah, it gives a nice, at least sort of baseline to compare other approaches against.
Yeah, Martin Thompson, there are other papers in this area that talk about evaluating binomials in MPC. One of the things we found that was interesting about the paper that we're looking at as the basis of this work was the very clear P equals 0.5 being the optimum for both efficiency and getting these error numbers down. But there is other work out there that's talked about using binomials with different values for P and working through all of that. So they have some numbers on that compare those with, for instance, evaluating Laplacians and Gaussians, and they have algorithms for that I think are interesting to look at. One of the things that concerns me in that area, though, is that there's, like I said in chat, there's a rather large corpus of work on differential privacy that looks at attacks on differential privacy that come as a result of the approximations you make along the way. And one of the things that I think some of these papers have been very careful with, and others I'm not as clear on, is the approximations they make. So if you're looking to do a binomial with a probability of 0.3, your approximation of that 0.3 in the computation of that one does have very direct relevance in terms of the security of the output. And so we need to do a little bit more work here. Personally, I'm not very happy with the numbers that we have here. I don't think these are anywhere near as good as they could be, and we need to do a bit more work.
Yeah.
Ben and I have been talking about some various ideas, and I've got a few ideas of my own to help sort of streamline this. One of the things that we haven't done, for instance, is we haven't looked specifically at histograms or vector sums and tailored the computation to that. And it may be that we can do some tightening in that regard, and it may be that we can also do some other things around these scaling parameters that will allow us to get much closer to this ideal.
Yeah, thanks, Martin. Yeah, one thing you mentioned that some other papers maybe look at like Gaussians. I think it is important to be careful there that like your approximation isn't sort of degraded and you don't sort of actually consider it. So it is nice in this paper that they look at the binomial directly and analyze its properties directly, what you get from that. So you kind of avoid a little bit of that potential approximation error. Thanks, Chris.
Chris Patton. So I'm not nearly as terrified, but I'm also like not super exposed to this stuff. Thinking about like just the latency, it's like 3 minutes. It's a long time to do work on a computation, but if if we're doing this once per batch, like, in the DApp setting, for example, I can imagine tolerating that latency. Of course, we want to like see if there's other paradigms for this. So, yeah, in general, I'm very enthusiastic about this work. I'd love to see this be built on top of DApp in particular, and I'm game to help out. I think I just want to hear. I think Martin said this before, but I think it's worth clarifying for the group. Why can't we use three-party honest majority in DApp today? The naive thinking being that you have a collector, you have a leader, you have a helper, so you have a network of three parties. So why couldn't they do this computation?
Well, I think it really just relates on what's your trust model for the leader. Now the leader needs to sort of fit within the, trusted not to collude with any of the workers. If you're willing to make that additional assumption, then at least from the trust model setting.
Quick terminology, it's the collector, leader, helper that he was talking about. The leader is not, we have a different concept of that in our system, and it's really confusing. It's the collector that's the one that is not part of the threat model there. And yes, you're exactly right.
Yeah, so it is a different threat model for working in.
Tim?
Yeah, I was going to respond to the notion of why can't we use the collector as a third party? Well, I think it's because DApp already allows, DApp generally tries to maintain privacy in the face of the defection of one of the aggregators, right? Or only one aggregator needs to be honest for the privacy guarantees to be upheld. But we already allow for one of the aggregators to collude with the collector based on the observation that, like, frequently in deployments, the collector and one of the aggregators will be operated by the same group. So, yes, I don't think that given that threat model, we could achieve like 2 out of 3 honest. Because we already assume that the collector and one of the aggregators are colluding.
Yeah, so Martin Thompson, Chris Patton and I have talked about an interesting idea that I thought I'd float here and get people thinking on. And that is, in DApp, we also have the entire population of clients that are submitting reports as a potential source of the third party, as it were. So the idea that that we sort of jointly came up with, I think, was to have the bits submitted by the clients. So you have every client submit some number of bits that could be your random samples, and then the job for the aggregators would be to add them up. That's free if those samples are in the prime field that you're operating in already. So the aggregators don't really have to do any additional work aside from selecting which one of those samples would be there. We have a whole idea about sort of hedging, which is a little more complicated, but that's kind of another angle that we have on this one potentially.
Yeah, that's a good point too. That the thing that you have to trade off there is that it's not going to reduce the size of N you need itself. And so if you don't have enough clients, you're going to have to do more work to hedge, I guess, as you say. But yeah.
Yeah, the suggestion there was that the clients don't necessarily get to choose which ones of their bits enter into the system, but every client could provide some number of bits. So if you needed to provide 10 million and you only had 100,000 clients, well, you might be asking those clients to submit 100 bits each, which sure. I think at the point we're doing 10 million, I think something's gone wrong. 100 million seems a little much,
yeah.
But let's see if we can work on getting those numbers down to something more reasonable. 3 minutes is fine. 3 hours is not.
All right. If no other questions on the DP draft or feedback, we'll just touch on briefly these 2 other drafts that were shared on the mailing list. One is a 3-party MPC, and the other is a pseudorandom secret sharing. So these are work that it's mainly Ben Savage, Martin, so Daniel Masniet had to have contributed to. So multiplications for Boolean circuits and the 3-party MPC is something we've done a lot of work on recently, particularly in how to upgrade it to active security or malicious security. So just like a high-level overview of sort of what this gives you here is you have a a semi-honest multiplication is going to require 1 bit of communication per helper, and then sort of 1 computation of an AES encryption to generate shared randomness. You get your malicious security upgrade in the 3-party setting, honest majority setting, a lot more efficiently than you do in most other MPC settings. Okay, so it tends to be like a like a sublinear sort of overhead in total for here. We have done some work on validation in batches, so 50 million multiplications, around 6 megabits of network bandwidth, 100 RAMs of 100 megabits of RAM to store the intermediary. So your memory cost sort of changes with your batch size or your validation, but otherwise, the amount of bandwidth you have to spend on this is pretty small. And then the other draft, which Martin should really tell you much more about, is this pseudo-random secret sharing, which is a method for sampling sort of shared secret randomness. It's sort of a building block of these MPC protocols. Every time they need to do an MPC, they need to sample some pseudo-random sort of shared state to use for masking their shares that they're sending around to other helpers in this 3-party replicated setting. Okay, so we aren't going to talk in sort of technical depth about these latter 2 drafts, but maybe would like to sort of open discussion, as Chris alluded to earlier, about what do you all think about sort of this direction of sort of 3-party MPC in the PPM setting. I think there have been some presentations on a couple of past IETFs to sort of tease this work as future directions, but now we have some documents that we've gone and written down some of the building blocks.
So yeah, I mean, I would say I'm most enthusiastic about the binomial stuff, especially getting it integrated into DAP. That is figuring out a 2-party computation way to do it. That said, this other stuff is, I don't know, my impression from looking at other standards bodies, and also just talking to MPC people I've gotten to know over the last few years, is this is probably the future of, this is the thing that's going to be practical and generalizable to new problems. So I think we should work on this. I think it would be helpful. It probably would help us if we can clarify what our use cases are. I think we have, with DAP in particular, we've tried to be very specific about the class of problems we're solving. So I think, yeah, maybe you want to speak to some of the immediate use cases you have for, let's say, the 3-party honest majority MPC stuff.
Yeah, thanks, Chris. Yeah, so on the first part, I think that's great that there's interest. I think we expected initially, the DP one has the most relevance in the short term. In the longer term, for use cases for these other ones, we are mainly motivated by the work that's happening in the PAT-CG. As some of you may be familiar with the private measurement standards work there for advertising, and we can definitely do a deeper dive on the use case and sort of how those protocols are shaping up in the PAT-CG. I think we've made some pretty good progress on some of the shapes of some of the APIs, but 2 main things that come to mind in terms of the use case is sort of aggregating histograms for advertising measurement, and the other one is sort of aggregating sort of feature vectors for ML on top of sort of ads measurement data. So those 2 sort of use cases both fit very nicely in, we need aggregation, and we also need to add some DP noise to them. There's also a little bit more that could sort of be needed to fully support that use case. There's some other sort of PSI work that's also needed to join things up. I think what we try to do is sort of break down that problem into sort of individual components here. So right now, just sort of introducing the general MPC that we would need to support some of the computations, and maybe in the future we can bring another draft that's more oriented toward the PSI aspect of that use case.
So what is the delta between those 2 use cases you mentioned? So what does DAP not provide that you need for histogram aggregation in your use case and model training?
That's a great question. So for model training, I think there's a concern of shipping features to the device. The design in sort of the latest ones in the PAT-CG, they allow the breakdowns or feature vectors to be sort of, we call it late binding. So they can be added later on the server side to a report that the client sends. So you don't need to send sensitive features onto the client that may be leaked, that may be business sensitive data. And so you don't have to, and it's also, as Martin is gesturing, is we also are motivated by minimizing client server bandwidth. So one of the things that we have seen in the use cases that we want to support, one is that, yeah, when you're doing a feature vector, you know, that's sort of like it's a dense object. The dimension does not need to be extremely high, you know, 64, 128 sort of dimension with some precision on a float in there. But shipping all that through the client is going to increase bandwidth. On the histogram side, a lot of times you don't just want to sort of aggregate a single histogram. You want to aggregate sort of many different histograms. And the histograms are generally like small in size, not too many bins. But even so, like that's going to increase the client server bandwidth a lot if you're shipping, you know, 100 different histogram bins back and forth to the client. So I think we're conscious of that. It's also I think there's several sort of scenarios where this late binding of the breakdowns is helpful. It allows for a little bit more sort of dynamic queries in the system where you can query the system on one set of breakdowns, you can sort of see the result, and you may be able to change your sort of breakdown scheme and sort of query it again, subject to the correct sort of way of doing the DP budgeting for your reports. But those are a couple of things that come to mind that we have sort of thought to add additional kind of functionalities on what is currently in the DAP itself.
Chris Frishak. Just some questions on the second one, because you're doing three-party honest majority, and I skimmed through the draft. I haven't read it in detail, but I assume you're considering the malicious security model as well. But I was wondering how you're thinking about the abort setting, because usually most MPC models assume that if the malicious party just drop out, then you basically have the computation stops. You don't necessarily leak the output to any of the parties, but computation stop. So depending on who the three parties are in your specific models, that could be disruptive, especially if, for instance, runtimes of 3 minutes or 40 minutes. Even if they're not malicious, something happens, they drop out. So are you considering that setting? Like, how does that fit in here?
Yeah, great question, Chris. So we are considering the sort of malicious security with abort, so that if a party does do something incorrect or malicious, the query will just halt. And that's mainly for performance reasons. As I understand, like you get better performance in that MPC setting than if you're trying to sort of guarantee output, even in the face of a malicious party. And I think we've just made the trade-off that sort of it's worth trying to reduce the computation cost in total. We hope that parties that participate in this are incentivized to participate. And so I think there may be other means that are like not related to like the core cryptographic guarantee here to sort of guarantee like, you know, SLAs and availability of these helper parties, and that can be handled in more, you know, contractual or other agreements to sort of make sure that people are actually participating and running the query. So I think we've at least tried to separate that and sort of take the win on the MPC performance in this setting anyway.
Tim?
Thanks. I just want to express my support for this work in PPM. I think this is very promising. In particular, like Chris Patton said, using the differential privacy stuff in a setting like DAP would be good, but it's not hard to imagine a bunch of different things at IETF, even beyond the PPM working group, that would like to have, you know, a well-standardized, I don't know if it's fair to call it a primitive, but a well-standardized and specified like mechanism for jointly doing differential privacy. I'm not sure it's ideal for PPM to be the place where like differential privacy stuff happens at IETF, but I think we've been around on this a bunch of times and there doesn't seem to be a better place. So yeah, I think we should do it.
Thanks, Tim.
Yeah, Martin Thompson, I want to put a little bit of color on the client side size constraints. Some of the things that we're looking at here are sort of around in the order of 100 bytes of submission from the client on a per helper basis. So a couple hundred bytes is the sort of order of magnitude that we're talking about for doing the sizes of histograms, where for something like DAP, that would probably be in the order of kilobytes rather than hundreds of bytes. And that's a pretty significant change in terms of the client side. And obviously it scales a whole lot better if you have larger histograms, you pay 1 bit per bucket or very small numbers. Whereas in DAP, the proofs get bigger and each bucket requires that you provide a value that's pretty significant in size.
Yeah, thanks for mentioning that, Martin. Yeah, that's one of the performance sort of benefits of this 3-party honest majority setting. You have different tools available for robustness or than having the client generate large proofs for you.
Okay, thanks to everybody for their comments on this topic. We wanted to reserve a few minutes at the end for anybody who had thoughts to share about observations from the SAG session. I think Chris Patton might have volunteered to share thoughts about that.
Yeah, that was my first time at a SAG meeting. I don't know how those usually go, but it was like everyone at IETF, like, you know, disagreeing, not understanding the shape of the problem, not knowing what to do next. But there does seem to be this question of IETF working groups are working on fancy crypto. By fancy crypto, we mean cryptography that doesn't fit into the boxes of primitives that we have, say, for building TLS. Or anything like that. So not like AEAD, not chem, not blah blah blah. We have blind signatures, partially blind signatures, VOPRFs, VDAFs, all of these abstractions that are used in like to provide fancier security properties. And CFRG has been the place for those before, but like, you know, there's a question of like whether that's the right place for us to take like new MPC things. The VDAF draft is already there. CFRG is already committed to reviewing and finalizing that draft. So the question for us is like, what do we do beyond that?
I'll note that that's been several years in the making and still in process at CFRG.
So I'm Deb Cooley, I'm Sec AD. So the goal was not to address fancy crypto. Yeah. Right? The goal, because I think that stuff generally happily is done CFRG and other places. The goal was to address crypto primitives, and apparently we possibly didn't state crypto primitives quite succinctly enough. I mean, this is a work in progress, right? It was not meant to be a fully fledged, I mean, it was a proposal, but it was not meant to be a done deal, right? So it was meant to get comments from the community, which we certainly got. But it was meant to address crypto primitives. It was meant to address things like national crypto requests and I guess what we tend to call vanity crypto, where we talk about it's sort of crypto primitives, not fancy crypto, right? So not the like bleeding edge new stuff. It's the bog standard old crypto primitive stuff that comes up. It's the, you know, the US wants their crypto and standards. I mean, there's various countries that want this, and there is vanity crypto. And it's only going to get worse with the post-quantum algorithms coming up. So it was meant to address that. It was not meant to address fancy crypto. So thank you very much, Martin, for bringing that up, because I had not even crossed my mind. So that was like, he stood up and I'm like, oh, whoa, didn't even consider that. It was definitely meant for we get asked to AD sponsor all sorts of things. If you look at the current request to AD sponsor the East Lake draft, That's an interesting document. I wouldn't call it cutting edge at all. So it's stuff like that. So it's what do we do with this? Do we publish it in the, does the ISC publish it? Do we publish as a sponsor? Do we let people get their code points based on drafts? Do we? And it's more targeted at code points, which the fancy crypto is not, right? You're not looking at code points for VDAPs, right? It's definitely code point oriented. So there will be a summary. We will work on the notes, so you can go back to the notes and look to see. We'll clean them up. We had somebody writing notes. I haven't even looked at it. I haven't even actually gotten a chance to look at the entire chat of that, because as you're listening to something and answering questions, it's hard to also look at the chat. So hopefully that helps.
Martin Thompson, I think there's a bigger conversation that we potentially need to have about the relationship with the IETF and CFRG when it comes to, I don't know, fancy crypto. I don't know what these terms mean. The sort of things that we're talking about doing here. And it's become sort of clear to me that if we ask the CFRG to do everything that the IETF wants to do in terms of new cryptographically related work, they're not going to be capable of doing that. We do too much. So that's a topic that I'm more interested in than the vanity stuff. I do appreciate what you were trying to do, and I think ultimately the direction that was heading was great. But I'm more interested in the bigger problem. Yeah.
Yeah. As speaking as chair of PPM and also chair of Privacy Pass, I can say that there is there's definitely a consistent problem here with where the scope of CFRG is not really in line with some of the emerging needs that are appearing in those working groups.
Yeah, and I think we're going to have a series of difficult conversations about each one of those different things. I think in Privacy Pass, for instance, you're talking about BBS or variations thereof. It seems to me that BBS, or at least the core parts of BBS, is something that's very much in the CFRG wheelhouse. But some of the sort of work around the fringes of that is IETF work, and working out the split there is very difficult. This MPC stuff is another one of those examples. I deliberately brought it to this group on the understanding that this is not particularly fancy crypto. This is like high school math stuff.
I mean, I recognize the word, which is good.
Yeah, it's pretty. Oh, yeah. And as Chris said, it's all just polynomials anyway. So, right. But
so we are over time. I think these are turning into some great hallway conversations.
Awesome. Thanks.
Thanks to everybody for coming to our PPM session, and enjoy the rest of your IETF Friday.
Thanks, Ben. Oh, meet this person. He has a paper about